Hi class, in this video we will be finding the area of regular polygons. So first of all, a polygon is a fully enclosed shape with all straight sides. So there can be no curves to a polygon. Okay, but a regular polygon, so it's a polygon, but all sides and angles have to be equal, such as an equilateral triangle, a square, or a regular pentagon, regular hexagon. Okay, so one property of these regular polygons is that they are able to be circumscribed, meaning that a circle can hit all of the vertices around the shape. So for instance, in this triangle, I can draw a circle that would hit exactly all three of those vertices, or a circle that would hit all four of the vertices here. Okay, so for an octagon, then a circle would hit all 8 of the vertices perfectly, and the octagon would fit exactly on the inside. Okay, so this question is, what's the area of a regular heptagon with side lengths of 6 centimeters and an apothem of 4.2 centimeters? So there's a couple new vocab words on here. Okay, so we have a regular regular heptagon, that's 7 sides. The prefix hepta would be 7 sides, with side lengths of 6 centimeters and an apothem of 4.2. So the side length is 6, so I can mark that. And the apothem is the length from the center of the polygon directly down being perpendicular. So we're able to draw in a triangle here. So that apothem is a length of 4.2, and we could calculate the area of that triangle. So area of a triangle is 1/2 base times height. So the base would be 6, and the height would be 4.2. So when we calculate that, we'll get 12.6 square centimeters. So that's the area of one triangle, but when we look at it, we could draw in a total of 7 triangles, since it has 7 sides. So the full area of the regular heptagon would be multiplying by 7. So 12.6 multiplied by 7. So multiplied by 7 is going to equal a complete area of 88.2. And that's square centimeters. Let's look. Looking at this problem, what's the area of a regular decagon at the right? Okay, so if we look at that shape, we could see that the apothem is 12.3 and a side is 8. So if I draw in one triangle there, then one triangle would be 1/2 times 8 times the 12.3. So calculating that, we'll get 49.2. So that's one triangle, but then we have 10 triangles because of the decagon. So 49.2 multiplied by the 10 triangles, we're going to have a total area of 492 square inches. So now if you can take a moment to calculate the area of this regular pentagon with an 8-inch apothem and 11.6-inch sides. In this problem, what's the area of an equilateral triangle with a side length of 10? Okay, so that means that all 3 sides are 10. So I'm marking up the diagram. Okay, so the apothem, or the height of this triangle, is going to be right here. So if I split the triangle in half, then half of that part is 5. So if I redraw this right triangle, that base part is 5, this part is 10, and we're looking for this x here. That's the height of the triangle. We need this in order to do our 1/2 base times height. Okay, so calculating this, then we have a right triangle, so we need the Pythagorean theorem. So a squared plus b squared equals c squared. We'll have x squared plus 5 squared equals 10 squared. So x squared plus 25 is 100. So subtracting 25 to both sides, x squared equals 75. And square rooting both sides, we'll get x equals 8.7. So that represents that height here of 8.7. The whole length of it is 10, so the area of the triangle is 1/2 multiplied by 8.7 multiplied by 10. So multiplying that together, we'll get 43.5 square units. In this problem, we're looking to find the area of a square with a radius of 4. So the key is to figure out what the meaning of a radius of a square is. Okay, so if I draw this picture, here's a square, then the radius is the distance from the center to the vertex, so it's that diagonal distance right there. That's the length of 4. Okay, so to figure out this problem, what we could do is draw in this distance here and draw in this distance here. So the problem is that we don't know the actual length of the square. Okay, but what we have is that whatever that length is, then this first distance, that height of this triangle, is going to be half of x. Similarly, this other part will be half of x. So now we're actually able to use the quadratic form, or I'm sorry, using the Pythagorean theorem to find x. Okay, so if we have a squared plus b squared equals c squared, then a squared is half of x squared plus half of x squared is equal to the hypotenuse, which is 4. So that's 4 squared. Okay? So 1/2 x times 1/2 x, 1/2 times 1/2 is 1/4 x squared plus 1/4 x squared. So a fourth of a square plus a fourth of a square is actually a half of a square. So bringing this work up, 1/4 plus 1/4 is 1/2. So we have half of a square is 16. So if half of the square is 16, then the whole square is 32. So undoing, multiply by 2. We'll get that x squared equals 32. So square rooting both sides, x equals the square root of 32, which equals 5.6. But then, so that means that a side is 5.6 and the other side is 5.6. Well, 5.6 times 5.6 gives us back the 32. So just like we had here, the area of the square is 32. This problem says, what's the area of a regular hexagon with a side length of 20? So marking it up, I'm going to put a dot in the center, and I'm going to create this into triangles. So if I find the area of one triangle, then I'm going to multiply by 6 to get the full area. Okay, so the side length is 20. Okay, so now the goal is for us to figure out that height right there. So if we have the height, then we're able to figure out this problem. So if I draw in one triangle here, well, one property of regular hexagons on why these particular shapes are so useful, we could see by looking at these regular hexagons. So they are able to tile. In other words, they all fit perfectly together. So we see these shapes in honeycombs or in chain link fences or in all sorts of other real life situations. And the only reason that they come together and fit perfectly, whereas other regular other regular polygons do not, other than the triangles and the squares, is because each of these each of these triangles, such as the blue triangle here, is itself equilateral. So what that means is that I can draw this blue triangle again to the side, and it's equilateral, so it's 20 by 20 by 20. So that allows me to figure out the height if I divide the triangle in half. So then I'm looking at a triangle where I don't know this height, but half of it is 10 and the long side is 20. So I could use the Pythagorean theorem to find that height of the blue triangle. So getting it, we'll get x squared plus 10 squared is 20 squared. So x squared plus 100 is 400. So subtracting 100, x squared is 300. Square rooting both sides, x is equal to the square root of 300, which is 17.3. So in that triangle, in this blue triangle, the height is 17.3. That means that one area will be 1/2 base times height. So that's 1/2 20 times 17.3. So calculating that, we'll get 173. But then we have 6 of these triangles all together. So multiplying that by 6, the full area is 173 times 6, which is 1038. So that's the full area of the regular hexagon. So now it's your turn to calculate the area of the regular hexagon. You might have to watch that segment again to see exactly what's happening. But we're basically breaking these into equilateral triangles, and there's 6 of the triangles. And in doing that, then our goal is to find the height, if it's 12 by 12 by 12. Once we get one of these triangles, you can just multiply by 6 to get the full area of it. Here your goal is to find the area of the square given the radius. That diagonal length is 8. So a hint would be to draw in this part and this part. Okay, so go ahead and calculate that area also. In this problem, it says Nancy has a gazebo shaped like a regular octagon. Each side is 8 foot long. Okay, so it's 8 by 8 by 8. And it says if the gazebo has an area of 222 square feet, what's the length of an apothem? Okay, so the whole area is 222. So we want to work backwards to figure out the height. So the apothem is basically a height of one triangle right here. That's H for height, which is also the apothem. Okay, so figuring out that height. Well, if we break this into 8 triangles, then we could start off by taking this whole area of 222 divided by 8 and get that each triangle will be 27.75. Okay, so The area of a triangle is 1/2 base times height. Okay, so that full area here, marking out this, the whole area is 27.75, and that's equal to 1/2. The base of one triangle here is 8, and we don't know what the height is. That's what we're looking to find. That's the apothem. Okay, so 27.75 is equal to 1/2 times 8, so that's 4. And that's 4 of the height. Okay, so finding h, we have an equation here. We could just divide by 4, divide by 4. So the height would be 27.75 divided by 4. So that's basically 6.9 feet. So that would be that dimension of the gazebo. That would be that perpendicular from the center of the gazebo, perpendicular to a side, would be a length of 6.9 feet.